So this last lesson of the year is all about modeling exponentials and logarithms. And this word modeling, we've used it before in math class, but really it's just a higher ordered way of saying writing equations. So that's what we're really going to be working on, is writing equations of exponentials and logarithms. But we're going to be doing that using technology, which is a regression. So in Algebra 1, you did this on Desmos, y1 squiggly line, mx1 plus b. That's essentially what we're doing today, but for two different types of equations, and they're not going to be on Desmos, it will be on the calculator. Before we can actually get to writing equations, though, we have to know what type of data we're working with. The first type of data we could be working with today is a linear equation, which means that the y values have what's called a common difference, which means we are going to either add or subtract numbers to find a pattern between the y values. A quadratic set of data is also a common difference, but it's called a common second difference, which means you are finding the change in the changes. So you'll have to do pluses and minuses twice to determine that it's quadratic. Exponential equations, on the other hand, don't add and subtract at all because they have what's called a common ratio, which means we are going to be multiplying and dividing these numbers to figure out the common ratio or the pattern. Now, I'm not really ever going to put the numbers like as dividing. I'm going to put them as fractions because fractions are division. But I'm just, for your notes, it's nice to see multiplication and division. So to be able to potentially create an equation for this table, we have to know what type of data it is. If we look at these numbers at the y values, can you find a pattern for these y values? Well, we don't. Yeah, well, let's actually just find the pattern here. If I was to go from 2 to 0, what would I do? Minus. And then from 0 to 2. Oh, I see a problem because those are not the same number. But I'm going to keep going on purpose. How do I get from 2 to 8?
Plus 2.
And then 8 to 18?
Plus 2.
And then 18 to 32?
Plus 16? Plus 14.
14, cool. Okay, so obviously those are not the same number. So this does not have a consistent common difference. However, if we check the second difference, which means we check the differences of my differences, how do you get from -2 to 2?
What happened?
How do you get from -2 to 2?
0.
What? You had to add 4. How do I get from 2 to 6?
4.
How do I get from 6 to 10? Oh, snap, look at that. So we have a consistent second difference. That's what this is called. So since the second time I did plus and minuses, that it was all the same number, this is called a second difference. And since the second difference was all the same, this information, this data set is quadratic. Yes? Okay, well, let's look at the second data set. What are all of those numbers doing? All of the y values, what's happening?
It's decreasing?
It is decreasing. Could I subtract a number or should I do a different way to make things smaller? Like maybe division. What are all these things dividing by? 3. So when we're talking about dividing by 3, we're going to say multiplying by a fraction. So instead of saying divide by 3, I'm going to say multiply by a third. Because 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. But I'm multiplying by a fraction. It's the same thing as saying divide by 3 is to multiply by a third. So since I multiplied and divided, this is called a common ratio. And since these numbers have a consistent common ratio, this table is exponential. Do you see how we're just looking for the patterns here? What about the patterns in the third table? What do you notice about those numbers? Now, here's the first thing I notice. I notice that I start with fractions and that fractions confuse us. So if I just ignore those for a second, how do you go from 1 to 3 to 9? Okay, we seriously can't figure out how we go from 1 to 3 to 9?
Plus 2.
Okay, if we try plus 2, this would be plus 2, and then this would be plus 6. If I keep that pattern going here, this would be plus 2/3, and this would be plus 1/9. It does look ugly. It's like 2/9. Are those the consistent numbers? What if we tried something else? I don't like this adding thing because it's all over the place. What if we tried something else? What else could we try? Multiplying by 3. Again, if we start where it makes the most sense for our brains, and we go from 1 to 3 to 9, didn't all of those multiply by 3?
Yep.
If I multiply 1/3 by 3, do I get 1?
Yep.
If I multiply 1/9 by 3, do I get 1/3?
Yep.
I hope so. And so since these all have the same number that we are multiplying by, that means again that they have a common ratio. And what type of data is this? Exponential, very good.
Miss, what are we gonna do after we finish this?
We have a classwork activity.
What, we have a...
Okay, what about this last one? Can you tell me something about those numbers? They what? Oh, the numbers are all divisible by 3. Cool. That's a great notice, but that's not really what I'm asking. I'm asking like the pattern. How do you go from 15 to 12 to 9 to 6? What number am I minusing every time? Is it the same number the whole time? Yeah, so that's called my first difference. And since the first difference was all the same, this is a linear. So the first thing that we do when we model data is we have to make sure we know what type of data that we're working with. So this is how we check to see what kind of data we're working with. Sound good?
Yes, ma'am.
After that, once we know what type of data it is, we actually need to be able to model the equation or write the equation. And we're going to do that using technology. And so I'm showing you this on my calculator on the computer, so it'll be weird with the screen going back and forth. But basically, when we want to write an exponential function whose graph passes through these 2 points, then all we need to do is take these 2 points and create a table so that I can type it into my calculator. But this part's really easy because like x's and y's are what go into tables, and coordinate points are always x's and y's. So I just make myself a little table here, and then I'm going to be able to type it in my calculator. We're going to write the steps down here just so you have them written down, but I'm not going to write them down again. Once you have a table, you press Stat Edit on your calculator, and you would type in the numbers. After you have it typed in, I'm going to press Stat Edit again, and I'm going to go over to the Calculate menu. I guess it would be better said Stat Calculate. And you're going to choose option 0, which says exponential regression.
What does that say? Stat and then the second.
Edit.
No,
Oh, calculate. It's like an arrow to the word calculate. When we've done this before in the fall, we used options 4 and 5 for linear and quadratic regressions. But now we're using them for exponential regression, so we have to change the number we're using to the number 0. So let's see what that looks like in the calculator. Everybody with me in your calculator, we press Stat. Stat is found kind of next to the arrow keys. It literally says Stat on there. And we click Edit.
Practice putting this in your calculator.
We just type in all the numbers.
I might have it.
I'm going to wait here until everybody's got their numbers typed in. Once we see all of those numbers on our screen, we would say y equal to 2 times 3 raised to the x power. Because again, the calculator tells you exactly what order to put them in and then what numbers. So when we were doing this problem, what we should have done is we took the coordinate points from the problem and made them into a table. The most common mistake I saw right here is that you're not putting the coordinates together. Coordinates go across from each other horizontally on a table. Don't write them in the other way because then it's going to give you the wrong answer. When you do all of the steps on your calculator, so you stat edit and then you stat calculate, choose option 0, this should be 5, open parentheses, 2 to the x power as our equation. Now this next problem is going to give these sorts of problems context. Let's say that we own a store that sells trampolines. Cool. The table shows the number of trampolines sold during a particular year that the store has been open. So we have all of this data. We want to use a graphing calculator to find an exponential model for the data. Here's the nice thing, is they straight up told us that it's exponential. So that means we know we're going to use option 0 when we run the stat regression. And my question for you is, think back to when you took Algebra 1 and you had tables of data. Did you have to type in all of the data? Or could you just pick and choose which ones you wanted?
Nah, you have to type it all.
Great, same thing applies here. If we have a table of data, especially for a real world problem, we have to type all of it into the calculator to be able to run a correct regression. So here we go. We go to stat, we go to edit. Don't worry about trying to delete stuff, just type over it. So I'm going to press 1 and press enter. I'm going to press 2 and press enter. You see how it's overwriting?
Yeah.
Just do that. Man, typing on my computer on Earth, this is slow. Okay, you should be typing as well on your calculator, not your phone. So once we have it all typed in, we press stat, we go over to calculate, and which option do I pick again? 0. Now again, you can scroll to 0, or you can just press 0, which I recommend because that's not as annoying. We go down to the word calculate, and we calculate.
I think that's what it is.
So when we type this, or when we write this out, this is going to be y equal to, we're going to save 3 decimals, so 8.45. This is ridiculous. When we keep going and it says predict the number of trampolines sold in the 8th year, since they told us 8 years and years is x, that just means that we're going to take the number 8 and we're going to plug it in right there because we want to know what's happening in the 8th year. So we have y equal to 8.457 times 1.419 raised to the 8th power. That's something you could type in your calculator as well. See how we have to have a calculator to do this assignment? This is not something we can do without one of these. So go ahead and type that in exactly the way you see it.
What'd you get?
When we do this, we should be getting y is going to be equal to 139.019 trampolines, but like that's weird. We don't count 0.019 of a trampoline. So what's the best way to count these trampolines?
139.0.
Yeah, just 139 trampolines. We wouldn't sell somebody like 0.19 of a trampoline. That's weird. I mean, it feels like that would just be like a leg of the trampoline, a spring for the trampoline, but yeah, it's when you buy the extra parts, you know? Okay, let's go to the next problem. It's not really any different, but it is a little bit different. We still have a table, obviously, but this question says the atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, and an atmosphere is a unit of measure, kind of like meters. You didn't know that, probably. It is both a thing, the atmosphere, and a unit of measure, an atmosphere. The table shows the pressures, P's, at different selected altitudes, H in kilometers. So again, we have an entire table. What should we do with this table? Great, so let's go do that. Again, you don't have to delete anything unless you specifically know how. You can just overwrite it. So we would do 1 and then 0. Oh my gosh, 0.55 and then 0.25 and then 0.12, 0.06, 0.02. Now I do have one extra, if you notice, hanging off the bottom. All you have to do is press delete and then enter, and it will get rid of it. Question says, use a graphing calculator to find a logarithmic model. That is not what we were doing a second ago. The keyword in the last problem said exponential model. So we no longer choose option 0. For a logarithmic model, when we go to our calculator, we're going to choose option 9, the one that says LN regression, which stands for natural logarithm regression. So after we have it typed in, which we already should, we press stat, we go over to calculate, and which option do we pick? 9. Not 0. 0 is for exponential. We pick 9, which the top should say natural log regression. But again, you just go down to calculate, and you press calculate. And we get these numbers. We write them into the pattern. Notice this pattern is different. You must follow the pattern, which means we write down y equal to 0.863 minus 6.447 times the natural log of x, just like it says on your calculator. Now, if you were to be doing this problem on an assignment or something, this would actually be counted incorrect. Look at what letters are in the problem, and look at what letters I used in my equation. What letters are in the problem?
P and H.
What letters are in my answer?
Y and X.
Yeah, don't want that. We need to change them back to the letters of the problem, which means I'm going to change this to P. Oops. And this one is H. Same way X and Y are. The next problem on here says estimate the altitude, which means a height. So what we're going to do with this problem is we're going to take the atmosphere number they gave me and we're going to plug it in. So this 0.75 atmospheres is going to go where the pressure goes, since that's a pressure number. So we are trying to figure out what H is equal to when you plug the number 0.75 into the problem. Well, that's something I can toss in a calculator because all of that is numbers. Yes, I know this LN are straight up letters, but that's a button on your calculator that you should know where it is at this point. So I'm going to give you a second to find me the altitude or the height. So when you do that, we should get, and if we round to 3 decimals, 2.718 kilometers. The last little section here is about what's called recursive notation, and it's kind of like a separate idea. So I actually want you to draw like a good old line, kind of separating it from the rest of the notes. It still has to do with exponentials and writing exponentials, but it's not going to be one we do in the calculator. It's one that we just rewrite something from the calculator. A recursive rule basically just means that every single number counts, and we have to do the whole pattern to be able to figure it out. So it wouldn't be like being able to plug in a number, it would be creating a sequence of numbers or a list of numbers. The way that this works is you start with the initial value, which is really just the number in the very front of the equation. And you tell the person reading your paper that it's the initial value because you have the 0 inside the f of x. The next part of this is the pattern. You say the next number, that's what n stands for, f of the next number is going to be equal to the multiplier, or the number in the parentheses, times the function of the one before it. Literally, all you have to do is take the two numbers from your equation and plug them into the recursive rule. So for me, in example 6, this first problem, I see I have the number 4 and I have the number 12. This would be f of 0 equal to 4, because that's the first number. 0 indicates the first number. 12 is my pattern number, so that just gets plugged into the next term. Remember, n stands for the next number, which means this is going to be 12 times f of n minus 1. Everything about recursive sequences and recursive rules for these functions will be the same every time, just this number changes and this number changes. Everything else about this should be the same. I should always see an f of 0 and an f of n. It's a two-part answer. But it's literally that simple. You just put it in this format, which means, can you guys do that second example? Write a recursive rule for the exponential function. So this problem looks like this. We would say f of 0, so the first term is 0.75, and the next term is 6 times the previous term, which just gives me a pattern and a place to start. We start at 0.05, We start at 0.75 and we multiply by 6 to find the next term. Multiply by 6 to find the next term, and the next term, and the next term. That's what this means.